So we have base 5, correct? So what can we say equals, guys? This is base 5 and this is base 5. What can we say?
2x plus 2.
Yeah. 2x plus 3 equals 7, correct? Write it down. We're working. Pick up a pencil. Thank you. All right. Then how do we get 2x plus 3 equals 7? What do we do to get that by itself? Remember, you do reverse BEDMAS. So we can't divide by 2 until we get rid of the adding of 3. So we have to subtract 3. We have to do the additions and subtractions first. We get 2x equals 4. And then we divide by 2. And x equals 2. And then we just send it and hope for the best. No. Whenever we solve, even in rationals, we could always, we could always go left side equals right side, correct? And check it out. So once we know what x is, we can plug it back in and see if we get them equal. So we go 5, 2 times 2 plus 3 equals 5 to the 7. Remember, when you're checking or verifying, that whatever's on the left stays on the left, whatever's on the right stays on the right. Okay? So here we're going to get 5 to the 4 plus 3, which is 7 equals 5 to the 7. Is that true? Yeah. Now some people try and get like a big number. Why? 5 to the 7 equals 5 to the 7. Yay. You done. Woohoo. I know I'm right. I move on. I know I'm wrong. I cry, regroup, and go back to trying to do the question again. Right? Like, you should know if you're right or you're wrong. Okay? What's the problem with B? Not the same base. So when I see 343, it doesn't immediately say base 7. But 49 screams base 7 to me. Remember, you're trying to make them the same base by putting the base to an exponent, correct? And I know 49 is 7 to the what? To the 2. Yeah. So we get 7 squared, and then x minus 2 behind it, equals, what's 343? Yeah, 7 to that 3. So then we have to expand that 2 in. So we get 7 to the 2x minus 4 equals 7 to the 3. What can we do next now that they're both the same base? Yeah, so if this is 7 to this exponent and it equals 7 to this exponent, then I can set those exponents equal. So I can go 2x minus 4 equals 3. Then what do I do? Add the 4. And I get 2x equals 7, divide by 2, and x equals 3.5, or 7 over 2, both of which are correct. Now I just send it and hope for the best. So I'm going to go 49 to the 3.5 minus 2 equals 343. Then I'm going to go 49 to the 1.5 equals 343. What's 49 to the 1.5? 343. They equal, I know I'm right. I should write check up here or verification. They know what I'm doing. Okay? And they match. Remember, you're always trying to make them be the same base, smaller though, right? Not same base, larger. Yeah? So, C, we have a 3 and an 81. What can we make them both be? 3. So we get 3 to the 5x minus 1 equals 3 to the what? What's 81? 3 to the 4. What do we do when we have the two numbers side by side with a bracket in between? Multiply. So we get 3 to the 5x minus 1 equals 3 to the 12x. Same base, same base. So I can say that the exponents equal 5x minus 1 equals 12x. I'm going to subtract 5x. and I get negative 1 equals 7x divided by 7. X equals negative 1/7. Yeah, someone's getting married. All right. Can you guys all grab your calculators? I want to show you how you can check with your calculator too. So, for these, everyone's paying attention? This is going to go into your y1. This is going to go into your y2. If you have the exponents that pop up, cool, great, awesome. If you have the, when you press the exponent up, you get like a little hat symbol, little roof, we'll call it. You have to put it in brackets. So if you have that little roof, you're going to have your y1 be 3 to the power of 5x minus 1. If you don't put the 5x minus 1 in brackets, it's literally just going to go 3 to the power of 5x and then subtract 1. Okay? So if you have the TI-83s, you have to put it in brackets. If your exponent pops up, you're golden. Just type it in. And then same thing here, y2 equals 81 to the power of 3x. This one you can get away with it. If your exponent pops up, you don't need brackets. Now please go zoom 6. Put it back to your standard window. So the negative 10, 10, negative 10, 10 window. We're looking for the answer 1/7. Everyone paying attention? So we're going to find out where those two intersect. So we go second, trace, 5, enter, enter, enter. Is everyone paying attention? You're getting a decimal, right? Okay, can you go out of that screen now? Go second, mode, the button right beside second. It just gets you out of that screen. Now go the xt theta n button. Press that. The xt theta n button. And press enter. Did your decimal just pop up there now? Now go math, enter, enter.
Can you go through those steps again?
Yeah, I will. All right. So, I'm going to do it one more time. If I lose you, sad. Okay. So, everyone's paying attention. No one's talking. So, in y1, we have the original equation. y2, we have the other one. Does everyone have that? Okay. Then I told you to go zoom 6, so you got a standard window. Okay? Now we want to find out where they intersect. So we go second, trace, 5, because 5 says intersect, enter, enter, enter. And you get a crazy decimal for your x, correct? But I don't know what that is for sure. But I want to get my calculator to turn it to a fraction. Now that's what my x is. When I recalculate another intersection, there'll be a new x. Another intersection, new x. But for right now, my calculator believes that's what x is. Okay? So we're going to go second mode. It's the button right beside second. It's just above mode is the word quit. So if you press second mode, it just quits whatever you're in. Okay? Then press the xt theta n button. It's the one that you press for x. It's the one right beside alpha. It's the one that you should be pressing to get an x. Yeah? Then hit enter. And it should show up on your screen, that decimal, correct? Then go math, enter, enter, and it'll turn it to a fraction for you. And what are you getting? Same answer we have. Yeah? Okay? Now, D, let's look at this one. So, this is more advanced than you usually get, but we're going to show it anyway. So, I get, paying attention, 3 to the x. 27 is 3 to the what? Is 3 to the 3. 3 to the 2 is 9. Okay, going back to grade 10, ready? Everyone put your pencils down. Grade 10 taught you this. So if I go square root of 3, we were taught to make rational exponents from radicals. In grade 10, you were taught to reduce a radical like we do in quadratic formula. You were also taught to turn radicals into rational exponents. A rational exponent would be just an exponent with a fraction. Okay? How do we do that? Well, what is the number? The index is this little number that's normally located above the radical sign right here. What is the index if it's not there? It's a 2, because this is a what root? Square root. Okay? What's the exponent on my 3 if there isn't one? It's a 1. You were taught how to write rational exponents. You could convert this to a rational exponent by doing this simple little thing. Taking this index and dropping it underneath the exponent. So I'm going to get 3 to the half. Now for everyone who does not trust me, go into your calculator and go square root of 3. Square root of 3, you got it? Okay. Now go 3 to the power of a half. And remember, if you have a TI-83, you have to put that half in brackets. What is it? The same. One is a radical version, one is a rational exponent version. Taught it in grade 10. It's like a whole lesson and then you work on it the next day thing. Okay? If it was like the cube root of 2, what would this become then? 2 to the 1/3. And in grade 10, you guys can't do this after 2 days. You're like, I still don't get it. Just drop that number underneath. That's all it is. It's crazy how in grade 10 things are way harder than if you learned it in grade 12. The brain can take it in much better. Sorry? Yeah, we'll go back to that one. So, we have 3 to the half. We agree that the square root of 3 is 3 to the half. Yes? So let's go back. So, we have 3 to the 3 for 27 times 3 to the half, which we can write as 0.5 if that's easier for you. It doesn't really matter. Because they're the same thing, right? Because it's a terminating decimal. If you had like 1/3 and you wrote it as some sort of terminating decimal, you'd be in trouble because it's not. Half and 0.5 are actually equal. Okay, what do I do when I have two bases that are the same, two exponents? We talked about this yesterday. What do I do with those exponents? Add them. So I'm going to get 3 to the x equals 3 to the 3.5. I'm going to add them. So what does x equal? X equals 3.5. How can I check it? Y1, Y2. Go. See if you can figure it out. Find out where they intersect. What does this say? Your turn. What do you suppose it is? Your turn. I know it's crazy. Look, there's a whole bunch of them. Try them out. Try them out.